Hi, welcome to another mini lecture. Topic today is trigonometric functions and special angles problem type 3. What is type 3? Let's go take a look. Our angles could be more than 360 degrees or more than 2 pi, or they can be negative. So you see an angle of 1050 degrees, another one minus 2 pi, another one 13 pi over 6 minus 240, and so on. So we are going to circle more than once around our circle, and that's what means type 3 here. So let's just quickly review what happened. So we have two styles of looking at the issue. We have the so-called circle version and triangle version. I'm running parallel versions of these things because it's quite possible that some of you have seen one or the other one back in high school. Either way, it's the same thing. So in the circle version, you have a circle marked with these angles. Remember, positive means counterclockwise, negative means clockwise. Degrees, you go from 0 to 360. In radians, you go from 0 back to 2 pi. And for every point on the circle, you have an xy coordinate, and based on what coordinate you have, you define these 6 trig functions. In the triangle version, you have a triangle. Let me color this one. This is a central issue here. So you have a triangle. You are focusing on some angle theta. With respect to that, you define the opposite and adjacent, and of course hypotenuse, always the longer side. Then the 6 trig function. For cosine, you have adjacent over hypotenuse. For sine, you have opposite over hypotenuse. Your tangent, you have opposite over adjacent. Secant, you have reciprocal of this one, hypotenuse over adjacent. Cosecant, it's hypotenuse over opposite. Cotangent, it's adjacent over opposite. In the circle version, you have coordinates of x and y on the circle for these special angles. For triangle version, you have to memorize these triangles. For 45 degrees or pi over 4, we have these sides. For 60 degrees or pi over 3, the sides are 1/2, radical 3 over 2, and of course this is always 1. For 30 degrees or pi 6, the angles, the sides are radical 3 over 2, 1/2, and that is again 1. Instead of going on a circle, in the triangle version, if an angle is given to you, first you figure out what's a reference angle. Reference angle is the angle made between the terminal side and the x-axis. So I've colored them in red here. That's what the reference angle of those 6 rays. You position your triangle in that reference position, and then figure out what your trig functions happen to be. So let's go ahead, take a look, and see how we are going to apply this. Issue number 1, what if my angle is more than 360 degrees or more than 2 pi? So what should I do? Well, what does more than 360 mean? It just means that you have gone around the circle several times. And what does negative mean? Negative means you are going in clockwise direction. So here, let's do it a simple way first. Simple way is I have an angle 1050. Well, where is that? Easiest way to handle these type of problems, perhaps, if it is positive, subtract 360 until you end up with an angle that is between 0 and 360. So I have I subtract it, I get angle of 690 degrees. That's still a big angle. I do a second subtraction, 360. I'm left now with 330 degrees. 330 is one of our special angles, so it's in your circle. 330 is first of all is less than 360, so if you go to the circle, see where it is. 330 is over there, and on your circle perhaps you have the following designation. If you have it memorized, I've written it. 330, you are at the location which is radical 3 over 2 and minus 1/2. Okay, radical 3 over 2 and minus 1/2. Now, with who? This is x, this is y, and we want to apply our trig function, whatever trig function we want. We have it in terms of x and y. So for example, here what's required is sine of 1050. Sine is just y. So if I want sine of 1050, first of all, it's same as sine of 330. When you go on circle every 360 degrees, you come back to whatever you had, and the sine is just a y value, minus 1/2. So that is where I'm getting this thing from. Okay, so what if we want to do the other one, secant of minus 2 pi, secant of minus 2 pi. Well, in this case we are dealing with radians angle, radians, and just as in the other case, you remember negative means this and positive means you are going counterclockwise. So minus 2 pi, it simply means I have gone clockwise and I came back to the beginning. It came back to 0. So in this case, you can always, if you have a negative angle, you can add to it 2 pi's, or you can add to it 360's until you come to between 0 and 360, or between 0 and 2 pi. So I take minus 2 pi, add 2 pi to it, so I get 0. So that means I've gone around the circle. Now this is same as secant of 0. Secant of 0, so I remember secant of 0. I am at this location. The coordinate of that location on the circle is 1, 0, and secant is 1 over x. Is that right? Secant is 1 over x, and 1 over x, 1 over x, my x is 1, so that just becomes 1. Okay, so this one became minus 1/2 and this one became 1. We have to practice this thing over and over again to become comfortable with the steps and become confident with the answers that we have. Remember, on questions like this, you don't have access on a calculator, you have access to your memory essentially, and you should be able to answer these kind of things quickly. Okay, how would we answer the similar thing with respect to triangle approach? Well, secant of 0 being 1, that is essentially same in both version of it. If you have 330, first of all, I said 330, it means I'm here, meaning I am in quadrant number 4. I'm in this location. So 330, the reference angle of it, if you remember that terminology from high school, the reference angle of it is 30 degrees, meaning 30 degrees left to become horizontal. So we take a triangle with 30 degrees, this one, just flip it over so that I put a triangle here. I put that triangle here that was 30 degrees. The sides where this was radical 3 over 2 and this was 1/2, and if you wish, that one is 1. So 330 is same as this angle minus 30. Excuse me, I forgot to put this minus 1. Let me rewrite it so it's clear. This is After you flip it over, this becomes minus 1/2. Okay, what is it that we want? We want sine. Sine of sine of 1050. Okay, so again, what is 1050? We have gone around the circle once, that is 360, another time that is 720, and another time that is 330 degrees extra. We came to here, that's 1050. 2 full rounds and an extra 330. We are just 30 degrees short of going back to the horizontal. So you can think about this thing. This is same as sine of minus 30 degrees, because now I have to go 30 in this direction to catch the same terminal side. Now what is the sine of that? Same definition as basic. Opposite over hypotenuse. Opposite, this is my opposite. Hypotenuse is always 1 in this formulation, so it becomes minus 1/2 over 1, which is my minus 1/2. So you noticed in this style, we went after the reference angle. We positioned our triangle in where it's supposed to be, put the sides, correct the plus or minuses, and then take the appropriate ratio and get our answer. Either way, there is some work involved. So there is essentially no free lunch here. We have to do some kind of a work to see what the answer is in any of these cases. So let's go practice some more. Cosine of 13 pi over 6. So we look at that. 13 over 6 means that's something larger than 2. So 13 pi over 6 more than 2 pi. So one way to approach this problem, there are several ways, several things you can do. Perhaps straightforward is subtract as many 2 pi's as it takes until you end up in the first circle. So how do we subtract it? We take a common denominator, that is 13 pi, multiply this by 6, becomes 12 pi. You subtract it, becomes pi 6. What does that mean? It means that I have gone around the circle, which is 2 pi, and then I go an extra pi over 6. So up to here I had gone through an angle of 2 pi, and then I am going an extra pi 6. So that's where I am at. So the angle cosine 13 pi over 6 is same as cosine of pi over 6. Well, cosine of pi over 6 must be memorized by now. Cosine of pi over 6, this is our pi over 6 here, and cosine of that, what is that? On your circle, probably you have a picture like this. So at pi over 6 you have radical 3 over 2 and 1/2. It's x and y, and this is your x value, so that's radical 3 over 2. Okay, so that's how we answer that question. How about cosecant of minus 240? Well, here, to make it more comfortable, minus 240 degrees, if it's negative, add 360s to it until you get some angle between 0 and 360. So either you have to make your circle and label it in the opposite direction, that's just going to make it that much more crowded with more numbers and more dizzying look, or do what we just did. We took minus 240, added 360 to it, we got 120. So now we know where we are. We are at this location. This is 120. We are at this location to 120. And then from your from your circle. So you have probably something like this. So you are at this location. The x and y of this location is what is it? Minus 1/2 and radical 3/2. So we say this is same as cosecant of 120. Cosecant was same as 1/sine or 1/y. So cosecant was 1/y, is that right? So cosecant is 1/y here. So we use that, and what do we get? Where are we? Cosecant 1/y, 1/radical 3/2, multiply it to clean it up a little bit, 2/radical 3. So I'll have 2/radical 3. Okay, if you want to do the other style would be, again, you have to locate where is minus 240. With the same style as we did here, you have 120. So minus, if you have minus 240, so you're coming here and ending at this location. This is minus 240. Your reference angle is this 60 degrees. Is that right? Your reference angle is 60 degrees. Why? Because up to here is 180 and you're going an extra 60. Okay, if it is 60, you go ahead and plant your 60-degree triangle in this location. If this is 60-degree triangle, what do you have? You have, this is 1/2 and this is radical 3/2 and this is 1. Now you say cosecant of minus 240, exact same as before, is secant of 120. A ratio of opposite is radical 3/2. Hypotenuse is 1. So let's, exact same thing that we wrote before. Cosecant of minus 240 will be same as cosecant of 120, and our hypotenuse is 1. The opposite is radical 3/2, and it becomes 2/radical 3, and we get the same answer. Now let's go ahead, try one more time. Cotangent of 19 pi over 6. 19 over 6 is more than 2, so we better subtract 19 pi over 6. It's a big angle. I subtract 2 pi from it. What do I get? Common denominator 6. 19 pi minus 12 pi. This is 7 pi 6. 7 pi 6. Where is that? That's slightly past the halfway, or 180 degrees. Here's my 7 pi 6. Here's the 7 pi 6. What is it that we want from that? So 7 pi over 6. We go ahead, we draw our circle, or we have a copy of the circle available. 7 pi 6, we have located our angle at 7 pi 6. We go and look it up. The coordinates x and y of that point is going to be what? Minus radical 3/2 minus 1/2. This is the coordinate. What is it that we want? We want cotangent. So cotangent of 19 pi over 6 is going to be, cotangent was what? Cotangent was x over y. Again, cotangent is x over y. So we have to x minus radical 3/2, y is minus 1/2, and ratio becomes radical 3. So we got this one, radical 3. secant of minus 660 degrees. What do we do? Well, let's go back to the comfortable region. Add 360 to it. At 360, I'm still at negative territory. Another 360 to it. Instead of repeated addition, we can do a division and so on. If you are interested, let me know. It becomes a bit more complicated. Like if you say, well, I have an angle of minus 10,000 degrees, what are you going to do? Keep adding. Is there a better way? Yeah, in that case there is a better way, but if you're interested, you let me know. So here we went around the circle twice and added additional 60 degrees. So where we are at location we are at the location of 60 degrees. So minus 660 means you have gone around the circle if you go a partial circle, it brings you here. If you want to go in the positive direction, what is left is 60. So that was minus 660 and this is plus 60. Now what? I want secant of minus 660. Well, that's same as secant of plus 60. And secant is what? Secant is 1 over x. So this point has coordinates what? 1/2 and radical 3 over 2. Is that right? That's 60 degrees on your circle. There is such a point. This is x, this is the y. 1 over x would have been 2. Secant is 1 over x. Let's show that again. We need to know the secant. Here's one more time. Secant is 1 over x. My x was 1/2, and so I end up with a 2 here. We are fighting over nitty-gritty detail here, but it's important to practice this over and over again so that you can answer each of these questions under like 10 or 15 seconds. It has to become second nature so that you are comfortable with these functions. Like your future is resting on sines and cosines, because these are expressions that are used for description of various type of waves you are going to see later on, and that is why they are being emphasized so much. So sine and cosine, secret of life, sine and cosine. Okay, so you practice this, and we are going to meet over perhaps more advanced stuff coming up. Until then, good luck and God bless.